Hello students, I am Preeta Prasid, ISMR MCA department. Welcome to the topic of parallel database systems part 2. In part 1, I explained about parallel database architectures and the need of parallel databases and the basic performance factors of parallel databases. So here I am going to explain about IO parallelism, that is how the data can be partitioned and what are the different techniques available. IO parallelism. So there are three techniques: round robin, hash partitioning and range partitioning. Round robin, that is the ith tuple is inserted into the disk I mode n. It means if I have 10 disks available, so if the first tuple, it means the first record will be going to the first disk because 1 mode 10 will be 1. So second record will be going to second disk. So it is the data is given equally to all the disks available. Hash partitioning. So hash partitioning, we have to apply any of the hash function for the particular attribute. It is called as partitioning attribute. It means for example, if I have a table like employee, so employee table will be having employee ID, employee name, address, age, salary and all. So if I am applying the partitioning attribute of salary, so the hash function should give the value, output should be numerical, that is 0 to n minus 1. So accordingly, as per that value, if it is I, then it will be the value, the data will be going to disk di. Next it is range partitioning. So here separate range values we have to make, that is the partitioning vector we have to make on the basis of particular partitioning attribute. So here for example, if I am considering the student, otherwise voters, if you are considering the voters, so voters age limits, like if I am putting the value 18 25 50, so 18 to 24, 18 to 25 will be going into one partition, 25 to 50 will be going into second partition, and the age 50 above will be going into the third partition. So likewise, so range, it means that is the we have to create the partitioning vector. So on the basis of the vector, the data will be partitioned into different disks. So round robin, I already explained, that is it is the simplest form of partitioning strategy. So data are distributed into various disks in the fashion first record into first disk, second record into second, and so on. Hash partitioning, that is here the hash function is to be applied on the particular partitioning attribute. So here in this example we are considering the department number. So if we have 10 disks to be distribute the data, then hash function h of department number, that is department number mode 10. So first department 1 mode 10. So the value is 1. So the first department values will be going into disk 1. Range partitioning. So here it is the salary, if we are considering as the range vector. So 5000 to 0 to 5000 will be going into one partition, 5000 to 15,000 in second partition, 15,000 to 30,000 in third partition, then 30,000 above into the another partition. So partition strategies must be chosen carefully to the workload of parallel database system, because the workload may involve many components like the attributes frequently used in any queries as filtering condition, the number of records in a table, the size of the database, approximate number of incoming queries in a day. So that all things to be considered while partitioning the data. So here range partitioning, it is good for the group by and equijoin, and hash partitioning, it is good for equijoins, and round robin, it is spreading the load and it is the most flexible one. And this is the example of join query. So here select star from new one, join new two on id base, on the basis of id, that is new one dot id equal to new two dot id. So here you can see from the two tables, new one and new two, so all the attributes matching one is combined into the another table, and then which one is not matching, that is 6 and 4 a4, that is not included in the final table. So these are the image showing round robin partitioning, range partitioning and hash partitioning, that is h1, h2, h3, h4 different according to the hash values the data is partitioned into different disks. And range partitioning, that is Jan and February is in one disk, March and April is in another disk. Likewise in list partitioning, that is one equally distributed the data. Next it is the advantages, drawback is given there. So round robin, it is ideal for the relations when we have to scan the entire relation, and the round robin is not good for the point queries. Point queries in the sense the query like select star from employee where department equal to HR. So the queries like that round robin is not good, because we have given the data partitioned in every disk available. So again the point queries are coming, again we need to scan the entire relation. So it is not good for the point queries. And hash function, ideal for the point queries based on the partitioning attribute. It means if I am applying the hash partition on department number and the query is coming on the basis of employee salary, so it is not good. Ideal for the sequential scans of the entire relation, and hash function is not ideal for point queries on non-partitioning attributes. So not ideal for range queries on the partitioning attribute. Then range, it is ideal for the range queries on the partitioning attribute. Comparison, so this we already explained. The round robin, it is scanning the entire relation, and hash function locating the tuple associativity, that is for example the relation dot a value equal to 25, and for range queries, that is particular range. And skew, hope you remember skew, that is the three factors which is affecting the scale up and speed up. Last video I explained it, that is the startup cost, interference and skew. Skew means if I have lot of processors available and the data is not distributed equally, and some of the processor is getting slower to complete the task, so overall execution will be depending upon that slowest processor. So that is called as skew. So here unevenness of workload or load balancing is one of the critical factors to achieve the linear speed up. So here two images are showing uniform workload distribution and skewed workload distribution. And here two kinds of skew, that is attribute value skew and execution skew, that is called as partition skew. So mostly the skews are happening within the hash partitioning technique and range partitioning technique. Round robin, it will not happen, because most probably it will not happen because the data is distributed evenly. And some values appear in the attribute value skew. Some values appear in the partitioning attributes of many tuples. All the tuples with the same value for the partitioning attribute end up in the same partition. So can occur with the range partitioning and hash partitioning values. Partition skew, that is with the range partition, badly chosen partition vector may assign too many tuples to some partition and few to the other. So it is like, for example, range partitioning, if I am giving the salary, three vector values are given, 1 lakh to 2 lakh, 2 lakh to 3 lakh and 3 lakh and above. So the employees within that organization, if it is 1 lakh to 2 lakh, 100 employees are there, and 3 lakh above only 4 or 5 employees are there. So what will happen in one disk, that is 100 employee records are there, in the another disk for the 3 lakh only 4 to 5 employee records are there. So that is called partition skew on the basis of partition vector chosen. So handling of the skew. So there are two methods for handling the skew in range partitioning, that is whenever we are reading the 1 by nth relation in available disk, n is the number of disk available for storing the data. So 1 by nth relation means 1 by nth tuple. For example, if I have 10 disk and I am reading the 10th tuple, and if I go to the 11th table, 11th tuple, the value within that partitioning attribute is again added into the partition vector. Then again the value is stored on the basis of that partitioning vector values. So what is happening? The load can be balanced equally. So the n denotes the number of partitions to be constructed. Duplicate entries or imbalances can result if duplicates are present in the partitioning attribute. Histogram is another option for handling the skew. that is histogram can be constructed scanning the relation or sampling the tuples of the relation. And forms of query parallelism. So there are two types of query parallelism, interquery parallelism and intraquery parallelism. Intraquery is again classified into two, that is intra-operation parallelism and inter-operation parallelism. And inter-operation parallelism is again classified into two, pipeline parallelism and independent parallelism. Independent parallelism means partition parallelism. So let's see one by one. Optimization of parallel query. So parallel query optimization is just selecting the efficient query evaluation plan, and parallel query optimization plays important role in developing system to minimize the cost of the query evaluation. It means that is we have to plan the query evaluation in such a way that we will get the output in less time. It means the response time should be less. Interquery parallelism. So different queries execute in parallel with one another. So here in image you can see that is in interquery parallelism, different queries are processed by different processors. So here the aim is scaling up the transactional processing systems, and it is easier to implement on shared memory architecture. And the problem here locking and logging must be coordinated by passing message between the processors. It means which processor want the data to read or data to write, so that is to be communicated, and cache coherency has to be maintained over here. And cache coherency problem, you may be knowing that before reading or writing to the page must be locked in shared or exclusive mode. So before unlocking the page must be returned to the disk if it has been modified. That is log strategy. Intraquery parallelism. So here in one query it is divided into different subqueries, and that subqueries are processed by different processors parallelly. So this is the example which is happening in the Informix database. And again interquery is classified into two, intra-operation parallelism and inter-operation parallelism. So intra-operation parallelism, example like parallel sort, parallel search, that is speeding up the processing of the query by parallelizing the execution of individual operations. Inter-operation parallelism means speeding up the processing of the query by executing in parallel different operations in a query expression, that is execute different operations in query expression in parallel. Intra-operation parallelism, that is the first one. So here you can see the subqueries. The subquery may contain different operations, so that operation is parallelized. It is done by the different process. Intraquery parallelism, that is inter-operation parallelism and intra-operation parallelism. So here intra-operation, each individual operation in a query is parallelized. Example parallel sort and parallel search. In inter-operation parallelism, different operation in a query expressed are executed in parallel. Example simultaneously sorting or searching operations. So see this image, type of the parallel query execution. So can you imagine which kind of query optimization technique is it? It is intra-operation parallelism. That is the single operation sort is parallelized over here. So two factors which play important role in parallel query optimization, it is total time spent to find the best plan and the amount of time required to execute the plan. So inter-operation parallelism, again it is classified into two, that is pipeline parallelism and independent parallelism. So pipeline parallelism, in first slide I explained, that is output record of one operation is consumed by the second operation without completing the first operation. So only useful for the small number of processors. And independent parallelism, it is providing the high degree of parallelism because multiple operations in a query that do not depend upon one another are executed parallelly. So for example, if I have different student records in different disks, so if I have to sort on the basis of percentage, so different disk is processed independently, and finally at the time of compile it will get sorted in decided order. So pipeline parallelism. So here you can see that is from the intra query, it is intra operation and inter operation. Then again inter operation is again classified into independent and pipeline parallelism. So here it is the pipeline parallelism. So the subquery is one operation, the output is given to the another operation and the output is given to the another. So like that it is pipeline parallelism over here. And in next slide it is independent parallelism, partition parallelism. So different operations without interacting each other, they are processing parallel. So that's all about IO parallelism. Thank you for watching.